Hydraulic systems are the most common application of the Pascal's principle. The hydraulic machine works on the same principle. The hydraulic machine, or more commonly known as hydraulic press, is used to lift heavy vehicles or objects with very little force. Two containers, joined at the bottom with a pipe, are taken and filled with water, and pistons are placed at each end. Now, when a force of F1 is applied at a piston A1 of lesser surface area, this is what happens. When force F1 is applied on piston of area A1, pressure developed is given by P is equal to F1 upon A1. Now, according to the Pascal's law, this pressure is transmitted equally and undiminished throughout the fluid. So, pressure exerted on piston of larger area A2 is also P, and it lifts the weight of force F2. So, pressure at A2 can be given as P is equal to F2 upon A2. Now, for both the pistons, the right-hand side of the equations can be equated, and we get F1 upon A1 is equal to F2 upon A2, which gives F1 upon F2 is equal to A1 upon A2. Now, let's see how hydraulic principle is beneficial for lifting heavy objects. So, in this case, first of all we take first the area A1 as 2 meters square, and area 2 is taken as 10 meters square, and we apply a force of 20 newtons on piston of area A1. So, if we take the value of F1 as 20, A1 as 2, A2 as 10, and we need to find out the value of F2. So, if we simplify this, we get the value of F2 as 100 newtons. Thus, larger piston will support 100 Newton load, that is 5 times the load on the smaller piston. So we can multiply forces using such a device. By further increasing the area of larger piston, or reducing the area of smaller piston, we can multiply force. The hydraulic press does not violate the conservation of energy. See how? If, for example, the smaller piston goes downwards by 10 cm, the larger piston will come up by only 2 cm. So, force multiplied by the displacement for both the pistons are equal, which we'll see later in the concept of work.